The society has been through a series of industrial revolutions, and each one has changed considerably the way we live. 5G networks will support a diverse requirements, be it from high capacity, high throughput, low latency, high availability, so that it can really support a lot of different applications and services. And for instance, you would be able to use smartphones, laptops, tablets, but also use it for IoT devices or for critical mission devices or services, as well for automotive connectivity. So the utilization of 5G networks is really very broad, and we only know a certain part of it at this stage. And the more we get into the 5G networks capabilities, we will see how much it will impact our daily lives and the business as well as the private lives. But you can think of already a couple of these use cases. For instance, network operators providing hotspots for very high speed throughput for instance, virtual reality downstreaming or uploading. Virtual reality needs a lot of bandwidth. You need several gigabit per second throughput. And especially when you're looking at 4K or moving into 4K from high definition to 4K and then to 8K, the throughput requirements will only increase. That's, for instance, one use case where you have this capability in certain specific hotspots of the network. Other use cases could be, for instance, that operators provide these kind of high throughput hotspots within transportation modes, like in a train or in a car or in a ship, or even in a plane, where you have used 5G networks for infotainment, for instance. You could also use another use case, for instance, would be that you can download or downstream from drones. You have drones flying around, and you can live downstream pictures and voice from drones. 5G standards are being developed by 3GPP, and it is expected that the specification work for the first 5G standards, which will be based on the NR new radio version, will be completed by 2018. While the first commercial networks are expected to be available around 2020 in the Middle East, for instance, for the Expo 2020, we can already see field trials happening in 2018 based on 3GPP standards. Spectrum is a key asset for communication service providers, as it really defines the coverage or the maximum coverage and the maximum capacity of a network, and how the performance of an operator is perceived by an end user. And with 5G really based on high data rates, high throughputs, spectrum becomes a very important aspect for operators. In 5G network, there are high bandwidth services. These high bandwidth services are very much spectrum hungry, and 5G opens the door for using higher frequencies such as the centimeter wave or the millimeter wave spectrum. Therefore, for instance, in US and Korea, who are early adopters of 5G, there has been the 28 gigahertz and the 39 gigahertz already specified for 5G. Among the frequencies which are already in use in the LTE networks, the 3.5 gigahertz frequency will be used in the future also for 5G, as it offers a good balance between coverage and capacity, and especially if it is utilized with the massive MIMO beamforming antennas. That is going to be a good balance, providing really high throughput on an acceptable coverage area. In the Middle East, the 3.5 gigahertz band is widely available and already in use for LTE networks, and it should be used also for 5G networks in the future, and therefore regulators have to ensure that operators get 100 megahertz bandwidth in order to see the benefit of 5G networks. We also have signed 5G MOUs with major operators in the Middle East, such as DO in the United Arab Emirates, STC in Saudi Arabia, Zain Saudi Arabia. And under these MOUs, we'll be collaborating to develop field trials and to prepare for the early deployment of 5G networks. Early deployments are important because we would try then the initial use cases and see how those use cases can be integrated into the networks. There are four key aspects which network operators have to look at while preparing for 5G networks. Those are the network architecture, the backhaul, the spectrum, and the site solution. From the network architecture perspective, it's the core network which will become more distributed in order to provide the lower latency. On the radio network perspective, it's going to be more centralized in order to provide the higher scalability. On the backhaul, of course, the network is going to gather more data at a higher rate, and accordingly the capacity of the backhauling has to be increased and the speeds also have to be adapted. On spectrum, as we said before, higher spectrum is needed in order to allow the higher throughput. So we're speaking about centimeter wave and millimeter wave, 3.5 gigahertz band, as well as the sub 1 gigahertz band, which is going to be at the 700 megahertz most likely, which will allow also to have 5G on a wider scale, for instance, for IoT applications. And last but not least, we also have the site solutions, where we will see the utilization of active antennas with beamforming, which means that the site solution will look different. And as well, we will have more utilization of small cells. So the site solutions which we have nowadays will need to be adapted to a certain extent to cater for the necessities of the 5G specifications. Nokia is getting ready for its first 3GPP based 5G product by 2018. This will be based on Nokia's 5G ready AirScale baseband, which will be upgraded into the Cloud RAN and to the 5G software. The core network will be based on 5G core and on Edge Cloud solution. Nokia is also working with the leading chipset maker in order to develop the device ecosystem for 5G. Let me conclude by saying that Nokia has the 5G products available and that we will continue on heavily investing in 5G R&D. I know for a fact that the Middle East and specifically the GCC operators are early adopters in new technologies.